bottom we need to do to the top. All right, we are going to start our Unit 2 review. This should have been handed out to you on paper, and make sure you have it out in front of you. You may have done this already, or maybe you're doing it along with me, but either way, make sure you're following along with me. Make sure you're getting the same steps as me, because this is how I will grade you on your final assessment that is tomorrow. Okay, so make sure all your steps align with me, and you're good to go then for tomorrow. So we're going to multiply and divide the following fractions, making sure we simplify first. So let's look at our first one over here. All right, so I have 21 25ths times 5 sevenths. So let's go ahead and look at our diagonal pieces of 21 and 7. All right, thinking of what goes into those numbers. Well, remember, factors are what goes into a number. So when I think of the number 7, I know that 1 times 7 is 7. 2, no, 3, no. So these are the only factors that go into 7. Now I want to see, does 7 fit into 21? It does. If you remember, 7 times 3 is 21. So we're going to divide by 7. Divide by 7. When we divide by 7, we get 1. So that's our new denominator over here. When I take 21 divided by 7, I get 3. All right, so make sure you are simplifying first, trying to find those greatest factors to pull apart. All right, let's look at the next one, 5 and 25. Well, I know 5 goes into 25 because it ends in a 5. So let's go ahead and simplify those by dividing by 5. And over here, 5 divided by 5 gives me 1. 25 divided by 5 gives me 5. So now let's go rewrite this new problem and see what we have. So over here we have 3. Our denominator is 5, so 3/5, times our new numerator over here is 1. Our new denominator is 1. And I like using those parentheses. Now from here, remember, we just multiply across, not at a diagonal, just multiply straight across. So what is 3 times 1? It is 3. 5 times 1, it is 5. And I got to double check, is it fully simplified? Sometimes it's not. But yes, nothing else can simplify 3 and 5. So that's my final answer. All right, let's go look at another one. 40 seconds over 9 tenths. Well, I know we can simplify 40 and 10 by dividing by 10 and dividing by 10 because 10 goes into 40, right? So 10 divided by 10 gives me 1. 40 divided by 10 gives me 4. So those are simplified. Let's look at our other way. 42 and 9. Well, 9 doesn't fit, but let's think of the numbers that make up 9 real quick. Well, I know 1 times 9 is 9. 2 isn't a factor. We take 3 times 3, we get 9, and that's it. Now, let's see. Does 3 go into 42? Remember my trick? What's 4 plus 2? It's 6. Does 3 go into 6? It does. So guess what? We can divide by 3. Let's go ahead and do that so we can make this smaller for us. Divide by 3 and divide by 3. If you didn't, that's okay, but eventually you're still going to have to simplify. So 9 divided by 3 is 3. 42 divided by 3. Well, if I don't know that off the top of my head, we've got to show some division. 3 goes into 4 once, which is 3. 4 minus 3, I get 1. Bring down the 2, I get 2. 3 goes into 12 4 times, so it goes in 14 times. So that's our new denominator. So let's go ahead and rewrite these fractions. Now our new fractions, I have 4 over this denominator of 14 times the 3 over 1. All right. Now let's make sure we're multiplying across, but there might be a step we still have to do. The reason I'm saying that is that these two are even numbers, so I know that fraction could be smaller, so we still might have to simplify. So what's 4 times 3? 12. 14 times 1? 14. And like I mentioned, it looks like we still need to simplify. Why? Well, they are even numbers. Any even number I can divide by 2. Always does that to me sometimes. So 12 divided by 2 gives me 6. 14 divided by 2 gives me 7. And now we are fully simplified. Remember, make sure you stop, pause this video anytime you need to catch up. All right, let's go look at some division problems. So we did 2 multiplying. Now let's look at some division. So we have 7/8 divided by 3/4. Remember, division is really multiplying by the reciprocal of the second number. So we leave 7/8 alone. We're going to times it by the reciprocal of 3/4. So what is the reciprocal? It is 4/3. You make sure when you see that division sign, you flip this number. Okay. Now, always check to see if I can simplify, and I can. What goes into 8 and 4? Well, I know 2 works, but I probably should go ahead and use 4, right? 4 goes into 8, so I might as well use that. And 4 divided by 4, I get 1. 8 divided by 4, I get 2. Can I simplify 7 and 3? Nope. Let's go ahead and rewrite this because it looks a little funny. So 7 stays. So we have 7 over this 2. We have a new numerator of 1, keeping this denominator of 3. So now, let me go back in to make this friendlier. All right, there we go. Now, multiplying just straight across. 7 times 1 would give me 7. 2 times 3 would give me 6. We've talked about this. Do I want this problem? Nope, this is improper. So I need to make it a mixed number. And to do so, I need to see how many times 6 goes into 7. And it goes in 1 time, which is 6. So then I take that 7 minus the 6 we just took out. And then we're left with 1 piece. Leave that denominator of 6 alone. All right, let's go look at the next division. Once again, if I'm going fast, make sure you pause it, stop it, so you can get everything written down. All right, next one. 10 twelfths divided by 1/6. Leave the first number alone, but multiply by the second number's reciprocal. So 1/6 reciprocal would be 6 over 1. Can I simplify? 10 and 1, no, but 6 and 12 I can. I know 6 goes into 12, so let's use that. 2 would work, 3 would work, but let's use the bigger factor. So 6 divided by 6 would give me 1. 12 divided by 6 would give me 2. Since we can't do 10 and 1, now we just multiply across, right? So we have 10 times 1 gives me 10. 2 times 1 gives me 2. I don't want that final answer, though, do I? So how many times does 2 go into 10? It goes in 5 times, which is 10. So guess what? Nothing else is left. 5 is my final answer. All right, let's go look at some mixed numbers now. Ooh, there we go. All right, so remember with any mixed number, whether multiplying or dividing, we have to make them improper first, right? And to do that, we take this whole number times the denominator. So 1 times 4 is 4, plus 3 gives me 7/4. Leave that denominator alone. Okay, have to do that to both of them. So we take 2 times 5 to get 10, plus 3 to get 13/5. So this is my new problem once I make those improper. I have to. All right. Okay, from here, can I simplify? Oh, dang. Unfortunately, I cannot do any simplifying here. So we have to multiply just across. 13 times 7. Well, if I don't know that right off the top of my head, I'm going to break it down. 7 times 3 is 21. 7 times 1 would be 7 plus 2 would be 9. So we get 91. And then 4 times 5, we get 20. So now from here, I need to see how many times 20 goes into 90. And if I count by my 20s, 20, 40, 60, 80. Can't go in any more than that. So it goes in 4 times, and I said 80. So we're going to take that 91 minus those 80 pieces we took out. And 91 minus 80 would be 11. Leave your denominator of 20. All right, so there's your first one, and no other simplifying needs to be done there either. All right, let's go look at the next one. All right, making it improper first. 3 times 2 is 6, plus 1 is 7. Leave your denominator of 2. 2 times 4 is 8, plus 1 is 9. Leave the denominator of 4. Can I do any simplifying? Man, just making it hard on us. No simplifying. Also, make sure you're not flipping. This is a multiplication sign, not division. Don't flip anything. All right, leave them alone. Okay, let's multiply just straight across. 7 times 9 is 63. 2 times 4 is 8. Now from here, I got to figure out how many times 8 goes into 63. If I'm not sure, I've got to do some adding. But I know 8 times 8 is 64, so it's got to be one less than that. So it's going to be 7. And 8 times 7 is 56. So we're going to take 63 minus 56. I'm going to make sure we set that up correctly. Make sure I'm taking away what I can. Because we don't take that, bring that 3 down. Remember, we got to borrow. Or we can count up. And now 13 minus 6 would give me 7 over the denominator of 8. And there's no simplifying that needs to be there. So that would be my final answer. Make sure you're stopping if you need to. All right, let's go ahead and look at our last problems of mixed numbers with division. So always, always, always make it in proper first. So 2 times 3 is 6 plus 2 gives me 8, leaving that denominator of 3. I'm going to leave the division sign so I don't get confused on what I'm doing. So make it improper. 2 times 2 is 4 plus 1 is 5 halves. So this is the division problem, but we know division is really multiplying by the reciprocal of this second number. So leave 8/3 alone. Now we're going to multiply by the reciprocal of 5 halves, which is 2/5. All right, so make sure you don't skip that step. All right, from here, can I do any simplifying? 8 and 5, 2 and 3. Nope, again, can't. That's okay. So multiply across. 8 times 2 is 16. 3 times 5 would be 15. Now, that is still an improper fraction, so let's go make it a mixed number. So I got to think how many times 15 goes into 16. It's once, which is 15. So the little pieces left would be 1. Leave your denominator alone. Can't simplify, so that would be my final answer. All right, let's look at the next one. 5 and 1/5 divided by 1 and 1/3. All right, make it improper. 5 times 5 is 25 plus 1 is 26 fifths. Leaving my division sign for now. 1 times 3 is 3 plus 1 would be 4. Leave the 3 as a denominator. Now, let's multiply by the reciprocal of our second number. So leave that first fraction alone. Then we're going to multiply it by the reciprocal of 4/3, which is 3/4. From here, can I do any simplifying? Ooh, I finally can. Well, one, I know they're both even. Does 4 go into 26, though? Nope, so we can only divide by 2, which is okay. Let's divide each by 2. And half of 4 would be 2. Half of 26 would be 13. All right, from here, let's see. Can we do 5 and 3? Nope, just those. So our new fractions, we've got 13/5 times over 3 over 2. So let's multiply across. So 13 times this 3. What would that be? We'll do that. 13 times 2 is 26. So we add that one more time. We get 39. 5 times 2 would be 10. Make sure you're multiplying, not adding. All right, from here, how many times does 10 go into 39? Well, I know 10 goes into 30 at least, so that's 3 times. And that would be 30. And so then we'd be left 39 minus 30 gives me 9. Leave 10 alone as your denominator. And there's no more simplifying, so that would be my final answer. All right, now we're going to go into some long division. So we've done some division, and then we've done converting these fractions into decimals. Directions are clearly stating, so make sure you see those. It's saying to round to the nearest thousandths. That's those 3 decimal places over, okay? So we have 1/3. Remember when setting this up, this fraction bar means divide. So what is 1 divided by 3? Remember, I like to read the problem up and down. 1 divided by 3. All right, so does 3 go into 1? It does not. So I'm going to put a 0 there because it doesn't fit. And know then that 0 times 3 would be 0. When I subtract that, I still have got that 1. Now, adding any decimals and zeros to that number doesn't change it right now. It's still 1. So once I add that decimal, make sure you bring it on up. Okay? So we're still with this 1, but we're over in this place value now because we filled out this one. So bring this 0 down. How many times does 3 go into 10? It goes in 3 times. then it's 3 times 3 gives me 9. Subtract to see what's left, and we've got 1. Now we're over in this place value because we've done this one up here. Bring down the 0. 3 goes into 10 3 times, which would be 9. Subtract that, I get 1. And you might see there's a pattern happening here already. So I'm going to go ahead and add another 3 because it does say round to the nearest thousandth. And then we're going to put that little sign on top. That means that number will repeat forever. So make sure if you see those repeated signs, your repeated problems, you just stop and put that sign on top. All right, let's go look at the next one. 7 eighths. This says 7 divided by 8. So I like to set it up as 7 divided by 8. So that numerator goes in the middle of your division. All right. Does 8 go into 7? No. So we add that 0. 0 times 8 would be 0. So we are still left with the 7. But we're on a different place value. So I'm going to add some zeros. Add that decimal and then bring it on up. So we did this place value. Now we're over here. So bring that on down. How many times does 8 go into 70? Earlier I mentioned that I knew 8 times 8 is 64. So we're going to use that again. 8 times 8 is 64. See how much is left. So 70 minus 64. We got to borrow, so I can't take 4 away from 0. Make that 10. 10 minus 4 is 6. So remember, if this number down here was bigger than 8 or was 8, then we picked the wrong number here. And we would need to go back and choose a better number to fit that, okay? So you want to make sure that has a smaller number right here. So we're done with now this place value that was right here. So we're going to move on over. Times does 8 go into 60? Well, earlier we did 8 times 7 was 56. So let's use that. And 60 minus 56, let's see. Got to borrow, bring the 10. Now 10 minus 6 would be 4. So I'm going to keep going one more because it does say the thousands, which is 3 places over. So we've done this place value. Now we're over to here to this 0. Bring it on down. Add a 0. Does 8 go into 40? And it goes in 5 times. So we get lucky and it stops. Because 8 times 5 is 40. Now that I've got my 0 down here, I know my problem's done. So 7/8 as a decimal is 875 thousandths. All right, I'm going to go ahead and start our word problems. So you're going to have 2 word problems. Remember, we're either multiplying or dividing usually because these are those kind of problems, okay? So 2 3/4 of a pan of brownies are sitting on the counter. You decide to split all the brownies onto 2 plates. How much of the brownies are on each plate? I like to think of pictures. Here's 1 pan of brownies. Here's 2. Then we've got 3/4 of one. So, well, that's not a great photo. There. So there's our fourths. Right, each of them have that. And then this is that missing piece. Someone already ate that one apparently. Huh? I don't want the line. There we go. All right, so this is what we have. We're going to split them into 2 plates. So I don't really want to sit here and just do a bunch of dragging of problems. We're actually going to set up what kind of problem. When I think of splitting that up, we are going to be dividing. Now let's make sure when we get an answer, it would make sense, okay? So we want to figure out how many brownies are on each plate. So how many did we start with? We started with 2 3/4. We're going to split them up into 2 plates. So I need to see that problem written. Now let's set up the rest of the problem though, because I need to make my mixed number improper. So 2 times 4 is 8 plus 3 is 11/4. I'm going to still show my division sign. How do I show a whole number as a fraction? I just put a 1 underneath it. Now, as we remember from earlier, we do not divide. We actually multiply by the reciprocal. So let's go ahead and write that over here. So we have 11/4, leave that first one alone, times the reciprocal of 2/1 would be 1/2. Can I do any simplifying? 11 and 2, 4 and 1? Nope. So let's just multiply straight across. 11 times 1 would be 11. 4 times 2 would be 8. Now, that answer still wouldn't make sense either, right? 11/8 of brownies? Nope. Let's make it back to its mixed number. 8 goes into 11 once, which is 8. So 11 minus 8 gives me 3. Leave my denominator alone of 8s. Now, I'm not done. It does say we need to answer in a complete sentence. And let's check to make sure, does my answer make sense? I had this many brownies, 2 3/4. I split them in half, right, pretty much? Would I possibly then on each plate, if I split them and put them over here, would it be 1 3/8? Yeah, that makes sense. So let's go ahead and write a sentence. How much of the brownies are on each plate? 1 3/8 of the brownies are on each plate. Remember, we need a sentence. Make sure you put a period at the end of it that answers the question that was being asked. All right, let's look at our last problem. A dime is a 1/2 inch wide. If you put 5 dimes end to end, how long would they be from beginning to end? So, a little picture. Okay, here's 1, here's 2, here's 3, here's 4, here's 5. It wants to know what's the distance from here to this one, okay? Now, you might be able to add that up. That's fine, but this is not that kind of problem, okay? Let's think of what we really would be doing. Repeated addition, if we were to add all these up, is multiplication. So we are going to multiply. So we're going to take the 1/2 times 5 dimes. Now, we got to make 1/2, multiplying that by, what's 5 as a whole fraction? 5 over 1. From here, can I simplify? Nope, nothing simplifies. So let's multiply across. 1 times 5 is 5. 2 times 1 is 2. Do I want that as an answer? Would that make sense? Nope. So let's go and make it a mixed number. 2 goes into 5 twice because 2 times 2 would be 4. So take away that 4 from the 5 to be left with 1 piece out of 2. Now, there should probably be a label with this one. The last one, there is no necessary label, just besides the brownies. We were talking about a 1/2 inch wide. So this is actually 1.5 inches. Now, what's the actual answer, though? How would I word this? How long they would be from beginning to end. So let's write that. The dimes would be 2.5 inches beginning to end. So make sure you have this label here too. That's important. All right. All right. So this is your review for your unit test. This is something you might be able to use on your test, hint, hint. So I would make sure I have all of this done and I have this with me ready on tomorrow. All right. If you need to go back, you can always rewind and rewatch this if you need to.